here, but he's going to give a presentation in the other session spontaneously. So welcome Katja and Alex for the first presentation. I think we do it 25 minutes at max, so then we can change and then we have enough space for all the topics. Okay, so the stage is yours.
Thank you, Mark. So the topic Stocken is about large language models and specifically about open source ones so that they can be used in whichever way one wants to use them. And what you will see here is different experiments we did and different models we tried and what exactly we tried with. So the challenge here is that very often customers cannot use the best LLMs available because this would mean that they need to send data outside the infrastructure of the customer, and this is in several domains not feasible. So in these situations, the people need to have LLMs which can be trained and fine-tuned or otherwise adapted with reasonable resources because they will be on their own infrastructure. They can run on-premise and of course they need to support the language in use because as we all know, English is very well supported everywhere, but this is not true or not equally true for all the other languages. A bit about the big picture here. The scenario that we wanted to investigate is we have different requests, customer requests coming into a company, and these requests could be questions, for example, in a chat, there could be emails that are being sent and need to be replied to, and all these go through an LLM and we generate answers automatically, either for example as chat messages or as emails. And the question of course is what LLMs can we use in their base forms and whether we can improve or fine-tune them and how. Using for that domain data, not only for the improving but also for the tests that we will talk about very soon. A bit more specifically now for the context that we tested with. This was under the auspices of the Raiffeisen Landesbank in Upper Austria. And we checked specifically short messages and messages that were emails. And for that, we had as the main data a number of frequently asked questions, curated ones, and as an alternative data set, a number of web pages that were actually, that contained in some form some of the frequently asked questions, but within within other types of content as well. And Katja will tell you more about how we synthesized all the data that we used for testing. But I can tell you more about what we started with. So we had some general data and some project-specific data. From the general data, we had the Dolly data set and the Open Assistant data set. Now, these both data sets are in English, so we had to translate them. I will say a few more words about that in a moment. But I just wanted to point out that the translated data sets that we have generated will be made available on Hugging Face after SwissText, and at the end of the talk, you can also find a QR code to a page which will provide additional information. And for the project-specific data, we had the FAQs I mentioned before, as already said, curated, the website content, which were actually web pages and PDF documents. The web pages had been cleaned up, so there was only the main content of the page, and we did deduplication as well, so that very similar pages were excluded from the data set. And we created also test emails, and again this is something that Katja will explain soon. And regarding the translation, as promised, a couple more words. We tested actually translation with 4 different models. One was Argos Translate, which uses OpenMNT. we used Opus MT and these two different ones from Facebook that you see here. And in the end, we ended up using the No Language Left Behind model, the one that you see here at the bottom in bold. This turned out to have the best performance. We manually evaluated the outcome of the translations over several different samples, and the NLB model generated the most natural sounding and accurate translations. But there was just one drawback, that the consistency was on the sentence level. So if you had several different sentences, a word in some situations might be translated differently between consecutive sentences. That was one problem. And we also had a couple of surprises. Katja found it very nice to see this in the first place. For those of you who don't speak German, this is the question, the instruction and the response in English. Who are the rappers? And in the translation, the model also added an assessment of whether 50 Cent is a good person or not. So this was something, there were some such small things in there. But I think now it is time to talk about the models and what we did with them. I'll hand over to Katja.
Yes. So as said, we had quite some requirements to our models, and one is open source, commercially viable, or let's say nearly commercially viable, and I will explain why. And that it has to speak German, which not so many models. We were left with only 3 basically: Eagle, Flan, and Falcon. The newest one, which is maybe like 2-3 weeks since it's been published. So the fully commercially viable among these 3 is only Flan. The Eagle and Falcon, the base models, the models themselves are commercially viable, but they are both using the data set to make them follow instructions that is questionable if it's viable or not. For example, for Eagle, you cannot find any information whether it is commercially viable or not. I wrote to the person who actually trained it, and he was like, I'm not sure either myself, because so at some point there was some data that was created by ChatGPT. The OpenAI in their terms of use have clause the generated data cannot be used to develop models that would be competitors to OpenAI models. So, but one point is that this data was curated by the person who created Eagle, so it was translated, it was then manually cleaned and adjusted a bit. Whether it is now what is called developed, what is called a competitor to OpenAI, if I'm using it for myself in my company, is it a competitor to OpenAI? That's a question. It probably has to, a lawyer has to answer this question. Same for Falcon. Okay, Falcon used ShareGPT, for example, dataset, which is the conversations between a person and ChatGPT that was available also online. Like Vicuña, for example, uses it as well. So it also makes it questionable whether it is really fully commercially viable. To the sizes, Eagle is the smallest, 7 billion, then Flan is bigger, and Falcon is the biggest. There is also Falcon 7 billion, but it doesn't speak German. So that's why we did this. The rest of the information is more maybe for the creating the experiments, running the Hugging Face, what kind of a model it is. For example, for Eagle, the prompt has to be in German because it basically more speaks German than other languages. Yeah. So then we also attempted some fine-tuning with the idea that, for example, if the model doesn't speak very well German, which could be the case, maybe we could teach it, and that's why we actually translated Dolly and the Open Assistant dataset, and also maybe better instruction following, because these are instruction following or chat datasets. Then we thought, okay, maybe if the model doesn't really speak very well in bank terms, maybe we can teach it with our web crawled pages, and having our FAQs, where there is a question and there is an answer, nicely prepared. Maybe we can do a fast and cheap fine-tuning that can improve. So one thing is that we trained Eagle on the web crawl data, well, to teach it better, but it was not really good because then it forgot the context and didn't really follow the instructions so well anymore, like the context from the instructions. It didn't take into account very well. And also some pages were not really cleaned, so there were some artifacts from, for example, from the PDF pages, and the Geschäftsbedingungen, the terms of use is a big part, and it also like flew in the responses after that very heavily. So it just needs maybe a bit more cure or just not go in this direction. Then we also tried, okay, it forgot the instruction following, let's do a little bit instruction following with our prompt template and our questions wrapped in the prompts. It did better than without, but still is not really usable. Well, at least, you know, we were time constrained, so if somebody like makes it with more cure, it probably could work and maybe a bit more data because we only had like 280 training samples. That's not much. Then we also tried to train Flan because, yeah, I will talk before, it also didn't really follow very well the instructions, and we thought maybe a bit more instruction following, but it still was not really good. So I will concentrate further on the base models rather than the fine-tuned ones. So the experiments that we did. So we thought, like, let's think of what might be the source of errors and let's start small. First, how good are the LLMs in general? Can they answer super simple question with the context provided? They can do more or less, and this is how it was built. So we have a prompt, you're given a question from a customer of a bank, which we took from the Q&A section, that is a question, then you have a context, take the answer from this context, and this was the answer from the Q&A section as well. Then we put it in all of the LLMs, we got the answers, and it was okay. And then we increased the complexity. We did the question answering information retrieval, so we have a set of documents, not already provided one answer, but a set of possible answers, and we used Mlynchyk as a framework to retrieve actually the most probable documents that can be relevant to our questions, and then we put it in the model. Okay, this one I thought better do with the picture. So we have our questions from the FAQ section, we have our documents, which was like, we had this experiment on 2 levels. First, only the FAQs. So we have one question, but all the answers from the FAQs to choose from. And then the question again from the FAQ and all the data where to find maybe the answer. So then this is the documents part, these are the answers, and then we have word embeddings where we put in the ChromaDB. This is the vector store where we can apply the most similar and get the most relevant documents. So we get n most relevant documents. This can be adjusted in the Mlynchyk. We chose 3. Then we put it in our prompt with the question, the initial one, the 3 most probable answers, and then we put it in LLM and we try to get the answer. So here the errors can come, of course, whether or not the correct question was actually found among all those. So this is the retrieval part, and this we could actually quantize quite okay, I think. So the approach was return top 3 most relevant documents. So this is nothing to do with the LLM. This is only the part of Mlynchyk, information retrieval, like vector search. Use one of the provided embeddings, so there is a couple to choose from. We used the chroma retriever, and we said, like, choose the top 3, and if there is one that is correct among those top 3, count it as a hit. And then to calculate accuracy, we just get the hits to the samples, and turns out OpenAI embeddings, of course, the best, but Hugging Face and Struct, which are open source, are also pretty good, so we lose just 29% of the cases in this case. Then we also we gave in our prompt to the models, if you cannot answer the question, do not. Like, say you cannot answer the question. So we wanted to see how much they follow this, because we already know that this 29% of the cases, the correct answer is not provided in the context. So we took a look. OpenAI still mostly answers the question, even if there is no context provided. Then Falcon also very eager to answer. The Flan doesn't want to answer even if the context is provided. So there was the context provided, and Flan still says, I do not know, I cannot say. And also in many cases it says that you cannot instruct Eagle, always answers, always, no matter how you do, it's always answering. The query complexity is also, of course, source of errors. We didn't do the experiments, but we did address in the test data. Now about the test data. We used here a little bit ChatGPT to create the test emails, because the emails we don't have, we only have the questions from the FAQ. So we just, in our template, we put the, like, you are the person with a random name, this is your question, you want to ask it, your email should be rather long or short. We put it in ChatGPT, then we manually adjusted it, the context, the questions, and we got 20 test emails with different degrees of difficulty. Some had multiple questions, some had some personal information, some were simple, and these were the results. So this was the OpenAI, this is our benchmark, what we comparing with, and so these were like simple questions, like did very well, more personal, correct, still pretty good. We have like whether or not the question was addressed is the first column, then whether the correct answer was given or not correct. If it had hallucination, then it's red. If it didn't, it's green. And the quality of language. So OpenAI did quite well. Then we go to Flan, and it's like the Flan is really like pretty disappointed. It doesn't give good results. Eagle, you have a chance with Eagle. Let's say, like if you put it well, maybe you'll get something, but it's also not the best. Among the open source, the Falcon was really the best. They do say in internet Falcon is the best, the Hugging Face scoreboards all led by Falcon, and in our experiments we also could say that it did the best. It gave the answer almost always, it was very often correct. It did hallucinate quite a lot though. Like it starts well, it gives you the good things, but then out of nowhere it, for example, gives you the wrong number for the taxon or something, which is pretty critical. So to have an eye on it, so it's probably the best and the most dangerous, because it seems super good, but then some unexpected outcomes. Then we also did Eagle and Eagle fine-tune, but I will not say about it because it's anyway, it was not really good. And just as a like wrapping up, so what we found out, Flan, very uncertain. When it gives an answer, it often gives it in form of copying from context. The Eagle always gives back the answer. It's very conversational. It even tends to create emails even if you don't ask it, while Flan just ignores your prompt of give me the email back. It just gives you, in best case, some copied answer, maybe a little paraphrase, but not much. Falcon, as I told already, it's quite good, but sometimes he even guesses, like hallucinates well. It was not given, but it kind of guesses the right answer, even though if it was not in context, maybe from general knowledge about banks, I don't know. It's also very conversational. Flan not very conversational in terms of running it. Eagle is the smallest, of course, the easiest to run. And also to set up is rather easier. Flan, like I had to spend a bit of time to understand why it doesn't produce anything reasonable at all. And then it still was not really good. And the Falcon, if you have GPUs available many, then it's very good. If you don't and you have to run, like offload it to CPU partially, it gets extremely slow. But if you have GPUs or on the SageMaker you can deploy it, then it's good. I have some fun examples, but the time is over. So, thank you. I hope you could follow.
Thanks a lot, Katja, Alex. Other questions?
I just have a question. You mentioned the number of parameters for each of these three models, but
actually all have 2048 except of OpenAI.
Okay, oh really? So that's
Yes, all the rest they have
so
2000.
so it's not limited by that. So you always could fit whatever you wanted to in the context. You never had it.
Almost.
Almost.
Sometimes the context would go a bit too long to produce, but in most cases, yes. Yeah, I think this is also. I think in LangChain also you can actually control the maximum amount of like characters or tokens that can be given to the model to consider it.
Do you have ideas to address hallucinations?
Well, we were also thinking like, you know, we showed our data to the, when we were trying to fine tune to the models, and after you do that, then it's really difficult, like almost impossible probably. But probably before you show this to the model, you can maybe use, like, at least in a way like we did with the FAQs, that if you provide the context and you know that there is the right answer in the context, like on the, you know, evaluation step, when it's, yes, in the production, then probably difficult, let's say. But before, in the evaluation, if you just know, okay, in these cases there was no information provided and it still did the assumptions, you can probably be sure that it at least partially hallucinated and try to address that, like, even.
Exactly. What most people do is they compare the context that was provided and try to isolate facts in that context and compare with the amount of facts or what exactly is in the generated answer. So if you identify factual information like concrete, non-generic information in the provided answer and there's no evidence of that in the context, and you want to keep it, you want to be absolutely certain you don't state anything wrong, then you can go back and say that part you didn't get from the context, try again, or you can try a different way, or at least you can do a bit of filtering afterwards on the basis of does it look like there is a hallucination in here or not. But of course, for many of these things, especially in vertical domains that are complex, the ultimate test is a human that reads it, and this is something that cannot yet be replaced. Because something that we didn't have time to explain, and you can see in the slides, in the hallucinations columns, there was, sorry, red and green, but there was also some yellow, which was for hallucinations that were, let's say, either harmless or positive. One example is, you can find more information about that on our website. So this is something that was not in the context, for example, but is a rather safe thing to allow the model to hallucinate on. It doesn't create a lot of problems. If, like Katja mentioned before, if it tells you the interest rates are X, and the X is entirely generated by the model, this is a very bad thing that should never go through.
Did you say you have 280 examples for fine-tuning?
Yes.
Did you do anything special for this low resource kind of setting?
No.
Just full fine-tuning with...
Yes. Just, yeah, just on top. Because also, you know, the prompt actually is the same for all of them.
Yeah.
So the hope was kind of that it learns the structure, the new prompt that we will use in the afterwards.
The information that varies is not so big, so...
Yes.
Related to hallucinations, have you tried playing around with the probability? I don't know how it's called for other than OpenAI models, like the temperature.
The temperature.
Yeah, like, so to change this value, so to try to reduce it to have the safest text possible, so that you don't go too wild in the probabilities.
Not for the hallucinations. We tried to do it in a, like before in the very beginning, when just to try to get maybe better result, but yeah, not for the hallucinations, it was running mostly the default settings, and if I'm not mistaken, it's 0.7. So it's quite, yeah. Yeah, maybe it could be.
Is there another question? The last one?
I'm a very similar project. Oh yeah, so will this project continue? Because I see a potential, like if you had the time and the resources to fine-tune the models, I see a potential also to try to reduce hallucinations by doing like what OpenAI did, by doing reinforcement learning to kind of, you know, like you were saying, you need to reread this by humans, but you could do it not in the production so that everything has to be rewrite, but only in the training setup where you use reinforcement learning to improve the way. Is it something you consider, you will consider? Or is it
Yes. Yes, this the intention, hope is that this project will continue and will eventually find its way into production.
But here I want to say RLHF does not actually reduce hallucination. If you look at the OpenAI technical reports, it increases it over supervised fine-tuning
Okay. Well, then
in the instruct GPT paper.
Yeah.
Like Katya said, the model we would concentrate on anyway, based on the results we got, would be Falcon. But as you can probably imagine, these are very late-breaking results that you're looking at here, because we only had the last couple of weeks to actually experiment with it. Because it is very promising, this would definitely be a worthwhile model to play around with and see how it can reduce hallucinations, how you can maybe moderate chattiness a bit, and so on. So there's a lot of work, but interesting work forward.
Okay. So thanks again.
Thank you.
Thank you.